What sensors do AGV systems use for navigation? Imagine a robot moving smoothly through a busy warehouse, avoiding obstacles and following precise routes without human help. How do these machines know where to go? That's where sensors come into play. Automated guided vehicles, or AGVs, use a mix of sensors to find their way around complex factory floors and material handling areas. These sensors help AGVs navigate safely and accurately, even in changing environments. One of the most advanced sensors used is called light detection and ranging, or LiDAR. LiDAR sensors send laser beams out in all directions to scan the surroundings. They create detailed maps by measuring how long it takes for the laser light to bounce back. Two-dimensional LiDAR provides a 360-degree view on a horizontal plane, detecting objects up to about 70 meters away. Three-dimensional LiDAR adds depth information, making it easier for AGVs to understand complex spaces. These sensors allow AGVs to localize themselves precisely by comparing real-time scans to stored maps, a process called simultaneous localization and mapping. This means they can navigate freely without fixed guides, making them flexible in dynamic environments. Magnetic sensors are also common. They detect magnetic tapes or embedded magnetic spots on the floor. Magnetic tape sensors follow pre-installed strips, guiding the AGV along fixed routes. Magnetic spot navigation uses tiny magnets embedded at intervals, which Hall effect sensors and encoders detect to keep the vehicle on track. This method is reliable and predictable but requires installing magnetic markers beforehand. Vision-based sensors are another key player. These use cameras to recognize landmarks, obstacles, or painted lines on the floor. Standard RGB cameras or depth cameras help AGVs see their environment and adapt to changes. Optical sensors can detect lines or tapes on the ground, guiding the vehicle along specific paths. Vision systems are flexible but need good lighting and robust software to work well in different conditions. Inertial measurement units, or IMUs, combine accelerometers and gyroscopes to track the AGV's movement and orientation. They help correct errors from other sensors and keep the vehicle steady, especially when external signals like GPS are weak or unavailable. Ultrasonic sensors emit sound waves and measure how long it takes for the echoes to return. They help detect nearby objects and prevent collisions. Infrared sensors use infrared light to sense heat signatures or reflected infrared signals to measure distances. While they are not primary navigation tools, they add safety by helping AGVs avoid obstacles. GPS sensors are useful outdoors or in large open spaces. They provide location data over long distances, but in indoor factories, GPS is often supplemented with other sensors for better accuracy. Finally, encoders and Hall effect sensors are used for tracking wheel rotations and magnetic field detection. Encoders help estimate how far the AGV has traveled, while Hall effect sensors detect magnetic fields for position referencing. In smart factories and Industry 4.0 settings, combining these sensors creates a reliable system that allows AGVs to operate independently. This mix of sensors helps AGVs navigate complex layouts, avoid obstacles, and handle materials efficiently. The choice of sensors depends on the specific needs of the operation, balancing cost, flexibility, and precision. This smart use of technology keeps factories running smoothly and supports the move toward more automated manufacturing processes.